Hello everyone and welcome to today's video where I will be exploring our dynamic drone navigation system which is built to navigate through cluttered environment like disaster zone. This system uses real-time sensors and adaptive navigation algorithm to guide the drone from a starting point to the goal point while avoiding the obstacle along the way. So the purpose of this system is to simulate how a drone could be used in a disaster response scenario, such as delivering supplies or locating survivors. Let's dive into the core of this whole drone simulation system. So first of all, we go, as you can see, we go 100 by 100 map to represent the environment, and within the map we got randomly generated obstacles. So you can see the 100 by 100 grid. We got a whole map environment, and then we go resolution 1 meter, we go 0.2 speed of the drone, then we got safety margin which is 3 meters to set the word obstacles, then we got turning in. But you know, this speed and this all the safety margin, you can set it whatever you like, whatever suits your environment. So then we go randomly event. Then obviously I go this randomly generated obstacle inside the map. Then I got the robo starting position to the top left corner, then the goal position to the bottom right corner. You'll see when I run this whole thing. Then, but these goal position, starting position, you can have your own. You can generate your random position. So every time you run the random position, starting and the random position as well. And then I go visualization setup. So display the map, then hold the current plot for overlaying for element, then plot the titles, plot the starting position as green square, then plot the goal position as diamond. You'll see when I run it. Now let's talk about the main algorithm of main heart of, I would say, of this code, the adoptive navigation algorithm. So this algorithm is basically allows the drone to move to its goal, and while avoiding the obstacles in a real time. So it works by combining two forces, the attraction force and repulsion force. So attracting towards the goal position, and repellion, so repellion force which pushes away from the obstacles. So as you can see, like obviously I got iteration, so loop for 2000 iterations. So what it does is this loop basically it runs up to 2000 iteration, and is simulating the drone movement. And for each iteration the drone basically scans the environment using the lidar. So using the lidar it scans the environment, and which provide the distance of the nearby obstacles. And this adaptive navigation function is basically responsible to calculate the drone new position, so and orientation. So based on the obstacle it detecting obstacle is it detects and the goal is trying to reach. So what it does is every time lidar sensor gives a value, is basically this whole algorithm is calculating, like uh, do I need to attract uh, do I need to attract, or do I need to repel? So if there is something obstacle, it will repel from it, and then start go back to the attraction thing and start going toward the goal. If there's a obstacle, if there's no obstacle, let's keep going attraction. It will keep going towards the goal position. Now I got this function to calculate the robot new position based on adopting navigation. This highlighted whole thing. This is basically calculating the robot new position based on the adoptive navigation algorithm, and it calculates the direction to the goal. So vector pointing towards the goal. It converts the goal vector to polar coordinates, then robot is attracted to the goal. then initialize the repellion force to avoid obstacle, then adoptive obstacle avoidance logic based on lidar reading. So whole function, what this whole function is doing is basically is in this code, in the part of this code is basically the attraction force is calculated by determining the angle to the goal, and applying a force towards that direction. So we calculate the goal angle towards the goal and apply the force towards the direction. Similarly, the repellion force is based on the distance measured by the radar scanner. So whatever the value of the radar scanners is coming to the robot is getting on based on those values, is basically it put the repellion force. So if the value goes above the certain point, it knows that there is obstacle, it needs to avoid. So these two forces are combined to determine the drone's desired heading. So where is going to uh, uh, head next, what's the next position. So these two positions, attraction and repellion force, is basically calculating where the drone is going to head. Let's talk about the function, which is basically for obstacle avoidance. So the drone basically needs to adjust its path to avoid collision with the obstacle. As the drone scans the environment, if it detects an obstacle within the margin, it will steer away from it. So anything getting scanned by basically lidar scanner, it whatever it detects, whenever it detects obstacle, is basically uh, what doing is scanning those obstacles by basically sending the rays in multiple directions and checking for collisions. And the distance is to the closest obstacle is stored into the array, which is ranges, which whose name is ranges basically given in this code. Yeah, so the array is basically storing the closest distance to the obstacle, and based on this value of distance, adoptive navigation logic is basically there to calculate the deviation force. So whatever the value is coming from this radar scanner into this array, and this adoptive navigation logic is basically using the value to calculate the repellion force. So the conclusion of this whole code is basically this system provides an adoptive method for navigating a drone through a cluttered environment. So the combining of adaptive navigation, obstacle avoidance, and a real-time radar scan is basically allowing the drone to safely reaches its goal, safely reaches the destination while avoiding the dynamic obstacles. So this system can easily adopt for the various applications, I would say, such as disaster relief or surveillance, or delivering any kind of complex urban delivering in any complex urban environment. So that's what this code basically holding. Now I will show you how this code is running. So this is my whole code, and as I run my code, you'll see a map with obstacles, and that's my drone, and it's avoiding obstacle just to reach its goal. There's another thing, like I got random obstacles, and if I run this code again, you'll see that I get different maps, so different obstacles in the map. So every time you run this code, you get different obstacles, and yeah, you'll see the drone easily avoid these obstacles and reach your goal. You can increase the speed as well. You can increase obstacles. You can make it more complex as well. So you can see like every time you run this, the drone basically the map basically changes the obstacles, and yeah, drone finds the way to reach the destination. So this was my whole project I did, and yeah, I hope you liked the video. Thank you so much.